everyone. In this section, we'll talk about defining quality. Our learning objectives are to be able to define quality as relative to a set of requirements and in terms of customer expectations. We also want to be able to compare the concept of quality management today to what it was in the past, and list the major milestones in the development of quality management over the last roughly 100 years. We want to be able to describe quality losses associated with not producing quality products and the economic gains arising from producing quality products through the use of quality methods. And finally, we want to look at a broad view of today's view of quality management. But first, how can we define quality? One of the most famous definitions is by Dr. Joseph M. Juran, one of the fathers of modern-day quality management. And as we'll see here later, also he's known for incorporating the human aspect of quality management. Dr. Juran stated that quality means fitness for use. However, a more precise definition, we could say, is fitness for use and meeting or exceeding customer expectations. However, another definition of quality, which is worth quoting, is from Dr. A. Bladton Godfrey, a modern-day quality guru. And in the 2002 article, he says the most fundamental truth is that quality is relative. The customer focuses simply on value, seeing it as a ratio of quality over price. And only when we offer more value than our competitor do we really succeed. And this definition goes beyond the idea that quality is simply being fit for a customer's use. It includes customer satisfaction. It includes efficiency in production and price competitiveness. It conveys the idea that not only is it enough for customers to make the products with the right characteristics, but the business needs to make a profit. It needs to be successful as an enterprise in order to truly have quality. Now, of course, as we all know, there's very many different dimensions of quality. This, of course, reinforces the idea that to define quality is very difficult. You can't do this in just one simple sentence. Quality may have different meanings for different products, or even for the same product. It has different meanings for different users, for different markets. For example, you may be interested in the performance, how fast something goes, how smooth something sands, how sharp something is, how wide something is. You may be interested in the reliability, how long does something last. You may be interested in the durability of a product or how easy it is to service. Today, people are also looking at a new dimension, sustainability. How much does our product impact the environment? How much waste does it generate? So quality must be defined for each product based on the particular customer needs, what they want in the product, and this is part of our course, this has to be done through measurable characteristics and their limits of variability. So for a complete definition of product quality, we need to stress the importance of identifying the needs and expectations of a customer. The product designer will take these needs and expectations, select features of the product, and create a design. Then the targets and the limits of these variations for these features will be selected so that the product can be produced at a reasonable cost while meeting the customer needs. These products, features, which must be measurable, we call critical to quality characteristics. And as we said, though, quality is going to be relative to the set of requirements. So we have functional requirements. For example, if it doesn't meet those limits, there'll be a breakdown, there'll be a loss of function. And then we have subjective requirements, well, aesthetic, optical requirements that aren't essential to the function of the product, but could have very important quality aspects. And as we said, quality meets or needs must meet or exceed customer expectations. But what does non-quality mean? What do we mean by non-quality? And here we have a quote from Warren Buffett. It takes 20 years to build a reputation and 5 minutes to ruin it. If you think about that, you'll do things differently. And we look at this in terms of costs, quality costs, a little bit later. Let's go back though. What was the past view? Quality management meant simply the product would come out of the line, would be inspected, and then either scrapped or possibly reworked. Preconception was that quality means to test. It means additional resources used for testing, time used for testing. This is very costly. This reduces your throughput, costs manpower, and it's very, very reactive. Something has happened, and therefore we either have to scrap or we can maybe rework. But things have changed since then. And we're going to go through now the major milestones that have happened in the quality management movement since the 1900s. Let's start in the early 1900s, when Henry Ford began the mass production of automobiles, the Ford Model T. Ford was inspired by the slaughterhouses in Chicago, where he observed the processing of the cow carcasses, and he decided to use this assembly line production for his automobiles, with workers doing specialized tasks, using specialized tools and interchangeable parts. This allowed, for the first time, well, almost the first time, fast and cheap production of automobiles, propelling the before craft production of cars to a huge industry. Now, this was going on, but we had important contributions to the quality movement from first in the 1920s. We can mention Bell Laboratories. They had been working to improve the reliability of their transmission systems. And Dr. Shewhart developed at the time the methods used today for statistical control charts. He applied these then at Western Electric, emphasizing the importance of reducing variation in manufacturing processes. Now, in England in the 1920s, Sir Ronald Fisher was working on improving agricultural yields using designed experiments. And later we had Dr. Taguchi also working on the development of designed experiments for product and process engineering. In the 1940s and World War II, we saw the use of statistical methods by the military in the US for the production of goods and ammunition. And after the war in the 1950s, there was the development of the science of reliability, which is why our products today last so long. But it really wasn't until after World War II that the more exciting quality concepts and movements appeared and moved towards consumer applications. For example, in the 1950s, Edward Deming, he was a colleague of Dr. Shewhart, and he went to Japan as part of their post-war rebuilding efforts, and he brought Dr. Shewhart's ideas of process control to the Japanese industry, in particular to the automobile industry. We also had the publication of Dr. Joseph Johan's Quality Control Handbook in 1951. He was in charge of applying and just disseminating the Bell Labs statistical quality control innovations in Western Electric in the 1920s. And he, as we said before, was one of the people credited, or the person credited with bringing the human element of quality into the quality movement. But then, of course, we come to the famous Toyota production system, which plays, of course, a huge role in quality management. And there's many interesting books dedicated to this, mentioning, for example, the original Toyota Loom Works founded by Sakichi Toyoda, and how these automatic looms would halt as soon as a thread broke. So defects would stop the line immediately, stopping all further production. The firm was then led later by his son, Kiichiro Toyoda, and he decided to move the production to automobiles after the war. And the firm, struggling, needed to work differently than their American counterparts. They realized they needed to reduce waste and be much, much more efficient and have much higher quality. And this developed the basis for what we call today lean manufacturing. And here, yes, Edward Deming played an important role in this development. And we need to mention, of course, the engineer Taiichi Ohno. He's considered to be the father of the Toyota production system, developing ideas such as the 7 forms of waste and just-in-time production. We also have the Ishikawa diagrams by Professor Ishikawa at the University of Tokyo, looking at cause and effect analysis. And while all these things are going on, the Japanese automobile industry surged to become a huge competitor to the big US automakers. But what was actually happening in the US? That's another interesting story. In the it was not following these amazing changes that was happening in Japan. But in 1980, Motorola made a huge step. Bill Smith, engineer, introduced the Six Sigma methodology, a data-driven, systematic problem-solving approach for process improvement following the DMAIC cycle. And in 1987, there was the creation of standards for quality assurance by the International Organization for Standardization, so ISO. That was then at the time called ISO 9000. And today we see the acceptance of quality as a critical strategic parameter in business planning. And we as consumers, we have a huge awareness of quality. We're interested in, as we said, different aspects of quality. We're interested in the reliability. We're interested in the performance. And today, more and more, we're also interested in how our products affect the environment. We're interested in sustainability. We want to look very briefly now at quality costs. So a quality cost study summarizes any economic losses that occur in an organization because of not producing quality products. And such a study would also then highlight the potential for gains which would arise from producing quality products through the use of quality methods. And in such a study, you would need to collect data on different types of costs in order to generate a measure called the total quality cost, or TQC. And this is a summary measure that reflects in economic terms how well an organization performs in delivering products that satisfy customers, but in terms of the expenses, the sum of the expenses required in producing quality process and the losses arising from producing defective products. And here we don't have an exhaustive list, but the 4 categories of quality costs and possible sources of these costs here are listed. And again, we should maybe note that these quality cost categories only include operating costs and don't include any capital expenditure. So any type of expenditure on equipment that would have a lifespan of more than a year. So these quality costs we call operating quality costs. And for example, we have the prevention cost, planning cost. Do we have a quality information system? Do we have enough training for our employees? Do we have process control implemented? What kind of improvement projects do we have available? And the cost of having quality system development. We have also then the appraisal cost. What is the quality of our incoming materials? How do we check this? Are we able to inspect and test our product at the end of the line or even as it moves through the line? And what about the integrity of our equipment? What cost does that incur? Then we have internal failure costs. And what this means is once you have a failure where it is in line, we have scrap, a cost associated with the scrap. We have rework costs. We have failure analysis costs. We have the fact that might have some production downtime. We've lost the capacity we've used to make those products, and we've also maybe lost capacity because we've got to do some repairs. And then just from having bad quality products, as we saw earlier, we have the yield loss, the cost of the yield lost. And then finally, external failure costs. And this is where we go back to Warren Buffett's quote. What can this mean? This is often underestimated. This can be a huge cost. We have the cost of returns. We have the cost of recalls. We have the cost of warranties, replacements. We have the cost of loss, and beyond that, of loss of customer confidence, loss of market. And then that could even mean a price reduction for our product. So a direct loss of profit, gross margin on our bottom line, and in the end, maybe a loss of reputation. So all of these costs in a quality cost study need to be considered in order to decide what we need in order to make a quality product. Now, our course does focus on Six Sigma as a way to reduce variation and to avoid defects. And we know that, for example, with our example here with a little automobile, if we assume we have 10,000 parts or processes, if we have 6,210 parts per million defective, or processes defective, then we would get no cars out of our assembly line that would be able to drive. If, however, we have just 3.4 parts per million, then 97% of our cars would come off that assembly line with good quality. So we're going to be focusing on this, but we should be aware of the total quality cost and of today's view of quality management. So here we have an excerpt from a presentation given by Dr. Manfred Seika, who's here in Munich, and he sometimes gives this to the TUM students. He's worked many, many years in quality management in the automobile industry. And he shows quality management as a set of enablers and results. Now, what these involve are people, processes, products, and then back to people again. And he divides this into two sides. You have the subjective side of quality management and the objective side of quality management. And so if you look here in this upper corner, you start with in order to have quality management, you need leadership. You need employees and a culture in the company and values in the company that are dedicated to quality. These are subjective ideas that support the objective of producing quality products through quality processes. And these then are translated into the objective targets, which become management targets, strategy targets, for example. Now, to do this then, you need to manage change. You need to accept and drive change towards a quality company. And these require then that you work with your internal and external processes with the suppliers, and these become then altogether enablers of a quality organization. Now we move to the results. Here we have, once we have quality processes and a quality mindset, we can get quality products. And so, what the customer wants in the products. This depends on the customer expectations to meet and exceed those. And then this translate as results of people that are interested. Who are interested? Well, customers interested. We may have stakeholders around us that are interested, and of course, the shareholders in the company that are interested in how the company is performing. Now, what does it take to realize all these different things? Well, we're going to look at the statistics, and we're going to look at processes, products, critical to quality parameters, performance, but it takes a lot more. And here we see on this slide that Dr. Saika has added all the different people or departments involved in a quality organization. For example, finance is very involved, right? You have people doing statistics, engineering. You have the design, you have the marketing, communication, corporate social responsibility, communication, ethics, supply chain production, the entire business strategy. So what you see here is that everybody in the company has a stake in quality. Quality is no longer just the inspection team at the end of the line that costs resources and time. Quality is a mindset and a culture, and it drives the company towards the goal of total quality management.